A python skin jacket costs $15,000 retail. The raw snake skin costs $40. What happens between a dead snake and a luxury garment is a process so elaborate, so labor-intensive, and so chemically complex that it takes 47 separate steps and 6 weeks to complete. And one mistake at any stage ruins the entire skin. This is what actually happens inside a snake leather factory, every stage from killing the snake to stitching the final product. And the process is more brutal and more fascinating than you imagine. Stage 1. The kill. It has to be perfect or the skin is worthless. The snake arrives alive. This isn't cruelty, it's economics. A python that dies before processing begins starts decomposing immediately. Decomposition loosens the scales from the skin layer. The hide is ruined. You can't reverse it. The snake must be alive until the moment processing starts. The method is a metal spike through the brain. No suffering, not because the factory cares about ethics, but because stress hormones flood the snake's system if it struggles. Those hormones cause the skin to contract and the scales to shed irregularly. A stressed snake produces unusable leather. The kill has to be so quick the snake doesn't know what happened. Within 60 seconds of death, the skinning begins. Wait longer and you're fighting decomposition. The worker makes a single cut from jaw to tail along the belly. The skin peels away from the muscle and fat underneath in one continuous sheet if it's done correctly. If the knife cuts too deep, you damage the dermis layer where the scales attach. Too shallow, and fat remains stuck to the skin, which causes rot during tanning. A skilled worker skins a 6-foot python in 4 minutes. The finished skin is inside out, covered in blood and subcutaneous fat, and needs to be in preservative solution within 10 minutes, or decomposition begins destroying scale integrity. Stage 2. The salt cure, where most skins get ruined. The raw skin goes directly into a salt bath, not regular table salt, but industrial-grade sodium chloride at 40% concentration. This isn't preservation like jerky. This is cellular dehydration at a level that stops all bacterial activity instantly. The skin stays submerged for 48 hours. Osmotic pressure draws every molecule of water out of the cells. The skin loses 60% of its weight. What comes out looks nothing like what went in. It's stiff, white from salt crystallization, and reduced to about 70% of its original size. But here's where 30% of skins fail. If the salt concentration is too low, bacteria survive and digest the collagen fibers that give leather its strength. You won't see the damage until tanning, then the skin falls apart. If the salt concentration is too high, the skin overcures and becomes brittle. Those microscopic cracks don't show up until the final product, when the jacket splits along stress points after 6 months of wear. Temperature matters too. The salt cure happens at exactly 15 degrees Celsius, 59 degrees Fahrenheit. Warmer, and bacteria activate despite the salt. Colder, and the osmotic process slows down, leaving pockets of moisture that rot during storage. Industrial facilities maintain climate-controlled rooms where thousands of skins cure simultaneously, and a single degree of temperature variation can destroy an entire batch. After 48 hours, workers scrape residual fat and tissue from the flesh side of the skin. This is done by hand with curved metal blades. Machines would work faster, but they remove too much material, weakening the hide. A skilled scraper removes 100% of the fat while taking 0 dermis. This takes 15 minutes per skin and determines whether the final leather is strong or weak. Stage 3. The chemical soak, 8 days of controlled decomposition. Scraped skins go into a chemical bath that sounds insane. Lime and sodium sulfide. These chemicals partially dissolve the skin. That's intentional. The goal is to break down proteins and loosen scale attachments just enough that the skin becomes pliable without destroying its structural integrity. This is a controlled rot, too little time in the bath, and the skin stays rigid and impossible to work with. Too much time, and the collagen matrix dissolves, and you're left with mush that can't be tanned. The sweet spot is exactly 192 hours at pH 12.5. Every 24 hours, workers manually agitate each skin to ensure even chemical penetration. Skins near the surface of the bath get more oxygen and degrade faster. Skins at the bottom get less chemical circulation and degrade slower. Without constant rotation, you'd have 50% of skins overprocessed and 50% underprocessed. Neither is usable. On day 8, the skins come out looking dead. The scales are loose. The color is grayish-white, and the texture is like wet cardboard. This is correct. What you're seeing is snake skin with all the biological components that would cause decay removed. It's no longer organic tissue. It's collagen fibers held together by scale structures, waiting to be transformed into leather. Stage 4. The neutralization, 30 minutes to save or destroy everything. Those lime and sulfide chemicals need to be removed completely. Any residual alkaline material will continue breaking down the skin during tanning, causing weakness and eventual failure. But you can't just rinse them out. Water alone won't neutralize pH 12.5 chemistry. This neutralizes the alkaline chemicals, but the timing is critical. 30 minutes is optimal. 25 minutes leaves alkaline residue. 35 minutes starts damaging the collagen with acid. Workers monitor pH in real time using electronic probes, pulling skins the moment they hit pH 7.0. Then comes multiple rinse cycles with industrial-scale water volume. Each skin needs 200 liters of clean water flushed through its fibers to remove dissolved salts. By the final tank, the water runs clear, and the pH is neutral. The skin that emerges is clean, but fragile. The scales are held on by minimal attachment now. Handle it roughly, and scales fall off in patches. Those bare patches can't be fixed. The skin is rejected for high-end products and sold to discount manufacturers who paint over defects. Stage 5. The tanning where snake skin becomes leather. Up to this point, you have processed snake skin. You have leather, material that won't decompose, won't rot, and will last decades with proper care. Snake leather uses chrome tanning. Chromium sulfate, at specific concentrations, binds to the collagen fibers and cross-links them permanently. This creates a stable matrix that resists bacterial decomposition, water damage, and mechanical stress. The chemistry is complex, but the result is simple. Organic tissue becomes stable material. The skins soak in chrome tanning solution for 18 to 24 hours. The chromium penetrates the entire thickness of the skin, binding to every collagen molecule. You can see when it's complete, the skin turns a light blue-gray color from the chromium. This color will be dyed later, but the blue indicates full penetration. Temperature is critical again. The tanning bath operates at 35 degrees Celsius, 95 degrees Fahrenheit. Warmer, and the chromium binds too aggressively, making the leather stiff and brittle. Cooler, and penetration is incomplete, leaving the inner layers vulnerable to rot. Industrial tanning facilities use computer-controlled heating systems that maintain temperature within 0.5 degrees Celsius. After tanning, it's leather now, not skin, is wrung out using mechanical rollers that apply 2,000 pounds of pressure per square foot. This removes excess tanning solution and compresses the collagen fibers, increasing density and strength. The wrung leather is thinner than the skin that went in. Compression removes air pockets and consolidates the material. Stage 6. The dyeing, where color becomes permanent. No one wants gray-blue python jackets. The leather goes into industrial dye baths, where aniline dyes bond chemically to the chromium-treated collagen. Snake leather dyeing is different from fabric dyeing. Fabric absorbs dye into fibers. Leather's collagen is too dense for absorption. The dye bonds to the surface. This means multiple applications with buffing between coats. Each color requires 3 meters 5 dye layers with 12 hours drying time between applications. Black is easiest, full coverage in 3 coats. Natural browns require 5 coats because you're building depth and variation. Exotic colors like red or blue need base coats, color coats, and sealant coats. 8 applications minimum. But here's the problem with snake leather specifically. The scales create texture that holds dye differently than the valleys between scales. If you just dip the leather in dye, you get dark scales and light valleys. It looks cheap. Professional dyeing requires hand application with brushes, working dye into every valley while preventing buildup on scale ridges. This takes 45 minutes per skin. The dyed leather is dried in controlled humidity at 25 degrees Celsius for 24 hours. Dry it faster, and the dye doesn't set properly. It'll bleed when the jacket gets wet. Dry it slower, and environmental bacteria start growing on the damp surface, creating spots. Stage 7. The finishing, turning leather into luxury material. The dyed leather is now durable and colored, but it's matte and rough to the touch. Luxury snake leather has a distinctive glossy finish that comes from finishing compounds applied in layers. First comes the base coating, a polyurethane resin that fills microscopic gaps between scales and creates a uniform surface. This is spray applied in a climate-controlled booth where temperature, humidity, and air pressure are precisely regulated. Too much humidity and the coating doesn't cure. Too little and it dries before adhering properly. The leather is buffed with 2000 grit sandpaper to remove any irregularities. This is done by hand because machines can't navigate the scale texture without damaging it. A skilled finisher buffs a square meter of python leather in 20 minutes, removing high spots while leaving valleys untouched. Then comes the gloss coat, a clear acrylic top coat that creates the signature shine. This is applied in 3 layers with UV curing between each layer. UV light polymerizes the acrylic instantly, creating a hard, scratch-resistant surface. The final layer determines the gloss level: high gloss for luxury products, semi-gloss for casual wear, matte for rustic styling. Some manufacturers add enhancement effects at this stage. Metallic flakes mixed into the top coat create shimmer. Color-shifting pigments create iridescence. These additives cost $400 per liter, but they're what differentiate $15,000 jackets from $3,000 jackets. The leather is identical. The finish is what you're paying for. Stage 8. The grading, where value gets assigned. Every finished leather is inspected and graded. This determines what products it can be used for and what price it commands. Grade A. Perfect leather. No scale loss, no scarring, no color variation. No thin spots. Less than 10% of skins achieve this. These go to luxury fashion houses for $800, $1,200 per skin. A python jacket requires 3 to 4 skins, meaning $3,000, $4,800 in materials alone before labor and markup. Grade B. Minor defects. Small areas of scale loss or slight color variation. These are still usable for high-end products, but the defects are cut away as waste. About 40% of skins are grade B, selling for $300, $500 per skin. Grade C. Visible defects. Multiple patches of scale loss, scarring, or uneven color. These go to mid-tier manufacturers who use them for accessories like belts or wallets, where defects can be hidden. 30% of skins are grade C, selling for $100, $200. Grade C. Rejected. Structural damage, holes or extensive scale loss. These are ground into powder and sold as organic fertilizer. 20% of skins don't make it past grading. This means only 1 in 10 snakes killed produces leather suitable for luxury jackets. The rest are downgraded to cheaper products or waste. This is why python jackets cost $15,000. You're not paying for 1 snake skin. You're paying for the 9 skins that failed during processing. Stage 9. The pattern cutting, where experience determines efficiency. The graded leather goes to pattern cutters who lay out jacket pieces to maximize usable material. Snake leather can't be stretched or flexed like cow leather. The scales create directional grain that tears if stressed perpendicular to scale alignment. A skilled cutter positions pattern pieces to align with scale direction. Sleeves run parallel to the snake's body. Back panels use the widest part of the skin. Collar and cuffs use areas with smallest scales for flexibility. One misaligned pattern piece means the jacket will tear at that seam within months of wear. The cutting itself is done with rotary blades that slice through leather in one continuous motion. Multiple cuts weaken the leather structure. Each piece is cut once and must be perfect because there are no second chances once cut. Scraps are scrap. A cutter works through one skin in 15 minutes, producing 85 to 90% usable pieces if they're experienced. Novice cutters get 60 to 70% yield and get fired after wasting $5,000 worth of material. Stage 10, the assembly where craftsmanship becomes product. The cut pieces go to seamstresses who specialize in exotic leather. Snake leather can't be sewn like fabric. The scales catch on standard needles and tear. Special needles with cutting points are used, and each stitch hole is pre-punched with an awl to prevent scale damage. The jacket is assembled inside out with all seams exposed. This allows the seamstress to verify that each stitch penetrates the leather properly without going so deep it weakens the material. A snake leather jacket has approximately 2,000 individual stitches, each placed by hand. Industrial sewing machines work too fast and rip through scales. Seam stress points, shoulders, armpits, waist are reinforced with additional stitching and backing material. These areas see the most movement and stress. Without reinforcement, python scale jackets tear at seams within 6 months. With proper reinforcement, they last 20+ years. The entire assembly process takes 18 under 24 hours of skilled labor. A seamstress can complete one jacket per week if nothing goes wrong. One stitching mistake that tears the leather means scrapping the entire piece and cutting a replacement from backup skins. This is why luxury brands maintain material reserves. Some percentage of jackets will fail during assembly. You're not buying one snakeskin worked into a jacket. You're buying one successful jacket from a process where 90% of materials and 40% of labor produces waste. The efficiency rate is terrible because snakeskin is unforgiving. One mistake ruins everything. From the metal spike through the python's brain to the final UV-cured topcoat, 47 distinct steps over 6 weeks transform a living reptile into a luxury product. Each step eliminates more skins from reaching the final product. What survives is rare because the process is brutal on the materials, brutal on the workers, and brutal on the economics that make a $15,000 jacket, the cheapest possible price for something that took 200+ hours of specialized labor to create.